Welcome to another Fenestration Canada podcast.
This podcast is a presentation of Quanex Building Products. For more than 30 years, Super Spacer Tri-Seal from Quanex Building Products has been the ideal warm edge spacer solution for commercial and architectural glass. With its unique triple seal design, Tri-Seal provides structural strength, durability, and outstanding thermal performance in the most demanding applications. Learn more at quanex.com. This podcast is a presentation of UL Inspiring Trust. This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
Okay, we're good to go now after a little bit of technical problems. This is the second show of the season 2 of Tech Talks. So Al, I'll leave it to you. I understand you have a guest today.
Yes, we have a guest today, Dave Goldsmith of FlyJam Canada. Dave is a co-chair of the Fenestration Canada Technical Services Committee, and he's also the co-chair of the Fenestration Association of BC Technical Committee, and also is a member of the CSA A119 Committee on Performance Standards of Windows. So Dave is one of the people that are quite involved on the technical side of the industry, and we're very happy to have him with us on the show today to talk about Mullions. And Dave and I have discussed this subject and other engineering subjects over the years, and I have a great deal of respect for his engineering knowledge and also his knowledge of the window industry. And I think that's one of the reasons he's on our technical committees to contribute in that way. And today we're going to have him share some content to do with Mullions as part of our Mullions series. We want to hear from a manufacturer. Of course, Dave works for a window and door manufacturer, but also, he, as an engineer working for a manufacturer, he's got a unique perspective on the both the challenges and the solutions to challenges that manufacturers face. So, Dave, I think you've been preoccupied with Mullions for quite a long time, and I thought maybe you could begin by telling us a bit about that.
Yes, thanks, Al. So my journey in the fenestration industry started in October of 1990, working for a then quite small window and door company in Calgary called Gino Building Products, which later went on to be acquired by FlyJam and Cornerstone Building Brands. But like many small companies at the time, we were fairly naive with respect to Mullions. We didn't have a computerized order entry system. People made their orders up on forms that had carbon for quadruplicate, and there's a sales copy and manufacturing copy and costing copy and all that. And they just basically wrote out whatever they want. I want a casement this large. I want a direct set unit this large, and then I want a direct set unit this large. And please mull A to the left side of B and C to the top of A and B. And so they could create basically anything their little hearts desired. But we were making all wood windows at the time when we started in 1990, and wood has quite good flexural rigidity. And I wasn't in the product development and design department at that time. I was in manufacturing engineering. So I was blissfully unaware of the regulatory requirements for windows under the old A440-00 system. And I'm just going to pick up my piece of paper. I printed one particular page of A440-00 just to let you know what the regulatory requirements were for Mullions under that system. It was a combination on composite windows. It said, to demonstrate compliance with this standard for a combination or composite window consisting of 2 or more windows, each of which has been shown to comply individually, it shall be necessary to demonstrate that the mullions separating the individual windows have sufficient strength and stiffness to support these windows when subjected to the appropriate wind pressure. So if at the time I had the gumption to approach the director of product development and design and say, how are we demonstrating this? He probably would have snapped at me rather angrily, well, we've never had anything break out there. I think that demonstrates that more than adequately. But then in 1992, 1993, it went from being 100% wood windows to being like 70% and then 90% today vinyl windows. And of course, vinyl has a lot less flexural rigidity. But at first, we had vendors test reports. We were making individual casement and direct set and fixed sash and awning units, and we were allowing them to assemble them like Lego. And we got into a little bit of trouble once or twice. Most of the time, housing in small buildings in rough terrain and within the city limits, they're not really exposed to the real design pressures that are going to demonstrate some problems with the mullions. But when I first started in product development, I was asked to go out with service to a house in Springbank, Alberta, which is in the foothills of the mountains with a great view of the mountains, and where the wind really kind of never stops blowing, and sometimes it blows quite hard indeed. And I went to this house, into the living room, and saw this massive window. It must have been 10 feet wide by 12 feet tall, and it was like creaking like a Spanish galleon, a rotten Spanish galleon on high seas. And the owner described to me that he had at a dinner party where they moved all the furniture away from the window and put down a tarp, and his guests were going, "Woo, as this window, went in like that." So that's how we became aware that it wasn't a good idea to make vinyl windows without any mullion reinforcing at all. And we gradually became more and more astute with regards to mullions. Initially, we, had a testing agency do some mullion testing for us, provide some span tables under the AAMA 450 standard and other various methods in NAFS. But there still are some companies out there, nobody who's a member of Fenestration Canada, I assure you, that are still a little bit naive with respect to mullions. And I have a little video that I could show you here of a job that, and so I'm going to share my screen here. Okay, share. Dismiss that and open this presentation that I had. And this is an infill in Calgary where the homeowner was their own general contractor, and they basically sought out the cheapest windows. And we actually had to replace the entire house package because of multiple issues. Frame corners had cracked and separated. The mullions were totally unreinforced vinyl. This particular homeowner wanted something in writing from the city of Calgary saying the windows were not code compliant, so she could attempt to recover her funds in court. However, the city considered the windows to be code compliant purely on the basis of having NAFS labels, even though it was self-evident they were faulty and did not meet code intent. As long as they had labels, as far as they were concerned, they would meet code intent. And so I'm going to hit play. This is our salesperson looking at this window, pushing on it, and you can see the mullions have absolutely no reinforcing and they're not properly supporting the glass, causing these types of issues. I've got a slide from a previous, where am I at here, presentation. So this was provided by UL Club of one of their customers who basically sent a mulled unit with the same kind of naive understanding of mullion strength of vinyl windows, just to see what would happen. And this is the result they got at a very low test pressure, the minimum test pressure under NAFS, which is 15 PSF. So you can see if you were actually exposed to those types of loads in reality in the field, that could be a major issue. Another thing, and this is a slide from one of Al's presentation, you need to be aware of more than just the bending strength of the mullion. You need to be aware of the end connection strength and the shear strength. So this is our window that we sent for testing in the largest size casement beside a direct set. And we got disappointing blowout test results at 1.5 times the design pressure, because our reinforcing didn't go all the way to the bottom of the mullion, and therefore it was not protecting the T-bar from the shear forces at the bottom of the mullion, and the vinyl profile simply sheared. So you need to be cognizant and do testing of that.
So this is it. You know, these photos are very interesting because they illustrate what sometimes people don't appreciate. Is that, you know, you do a NAFS test of your individual units, they don't fall apart, they don't break, and you're very confident of how your product performs. But then you try to assemble them like the picture of that large combination assembly window. And it's, you know, just a lot of people feel intuitively that the windows will be strong enough when you put them together. And it's only when you start testing it in the lab that you really see how it performs. Of course, the springy window that you can push with your hand is always a bit of a worry, right? You know, if a simple hand pressure can actually make the window wobble in the opening, it's not a good sign, you know, in terms of it being strong enough. But I think this photo here that you pointed out just shows why it's important to test windows, because you just never know what the failure point is going to be until you start cranking up the pressures into that you know, structural test pressure, which is 50% higher than your design wind pressure, and find out how the product behaves. And this is where, you know, failures are actually how manufacturers learn to build better windows. And this is one of the reasons why we test them in the lab. So it's, you know, helpful for people to appreciate this kind of thing does happen when you get into the lab and test your products.
So, you know, what you really want, and we're going to talk a little bit later about the application of AAMA 450 to, you know, check mullion deflection. From my perspective, in a combination of testing and calculating regime, what you need to do is you need to eliminate the connections so that they are not the weak point. And you need to eliminate factors such as buckling of a reinforcement under too high of a bending moment so that it's not a weak point. And then you can use standards like AAMA 450 to reduce the amount of physical testing that you might have to take using a deflection limit of L over 175. Then you only need to calculate the deflection and you don't need to worry about those other factors. So just to give you an example of approach that you might take, so this was a newer product that was meant to compete against commercial windows at larger sizes, and it's just a vinyl window with aluminum cladding in and out. And so to be able to get rid of that weakest link, you know, we found we needed a shoe. So this thing shown in yellow is the reinforcing. This is a shoe that transfers the loads to the frame at the connection, and then the screw connections under there. And then this was an example of a mullion connected to another mullion. And so then we went to a test lab and test this, and we found that the shoe was no longer the weakest link. The screws would pull through the frame, and we had to do some more reinforcing at that point until we could finally, you know, prove out that was not the weakest link. I'm going to show you a video of a 2-light unit at 3,960 Pascal blowout test pressure to confirm that those end connections were not the weakest link. So you can see it's deflecting quite badly. Then the glass breaks and it springs back, and with no residual deflection, and the end points were not the weakest link. The glass was the weakest link. It was deflecting far more than L over 175, which is the assumption that you're strongly enough supported that you're not going to bend more than that at the design pressure. So obviously your glass is going to be your weakest link at that point. So let me try and stop that video. And we also did a 4-light, and we found, interestingly, on that one, and this was at 4,320 Pascals, that it just buckled and kept going and going and going so that the bending moment turned out to be the weakest link. And here's a fellow that walked straight in from the shipping door trying to get his hair full of glass or maybe a glazing stop to hit him in the face. You can see that it's bending so much, and once it buckled, the glazing stops actually popped off there. So that was interesting, but it did the job in confirming that that was not the weakest link, and of course we would never allow it to deflect that much in service, so that therefore the bending moment and the buckling would also not be the weakest link. So I think that's about it for the material I want to present, so I'm going to stop sharing and we'll continue.
So just so you guys know, we do have someone who wants to speak with you guys. They have a question, so if you're okay with that, I'll patch Sunny in. You good?
Yep.
Okay, so Sunny, you should be online now. I think you're muted. Just unmute you.
Yeah, hi, can you hear?
Yep.
Yeah, the question was just regarding the bending and shearing. How is that best prevented during handling and transport, other than the use of, I guess, brace is probably the expected answer?
Well, yeah, we don't. I mean, on larger, heavier units, you'd want to say brace with 2x4s and cross bracing and that type of thing for shipping and handling, particularly if you're going long distances. Otherwise, you wind up with phenomenon like broken frame welds that would require the whole thing to be replaced in the field due to shipping and handling. But the NAFS testing really only deals with it in the installed condition, assuming that it got to site in one piece and was properly installed.
Okay, thank you.
Thanks. So I think it's a good moment to remind everyone, if you have questions, we can patch you in just like what we did, or you can use the Q&A section for both Dave and Al here. So I didn't want to stop you guys, but since we had a question, I just felt like we could answer right away. So yeah, you can keep going.
Okay. So Al, did you want to start getting into the questions and such that you were suggesting that you wanted to ask me?
Sure. I think for manufacturers that are dealing with mullions, qualifying their mullions for the first time, what advice would you give them? Where do you begin, especially if they're a manufacturer with no engineers on staff?
Well, then you really need to rely on the advice of the testing agency, and you basically would hand them all your drawings and say, this is what we make, and this is the various types of combinations of products of product configuration in composite assemblies and combination assemblies, and what is the least amount of testing that we can do to satisfy the NAFS requirements for these types of units. And then, I would encourage, particularly larger companies to have engineers on staff, and particularly if you are selling into non-Part 9 projects where there's third-party professional review, then you need the ability to do that kind of engineering analysis in-house in order to predict the type of reinforcing and the type of glass thickness that your third-party supporting registered professional is going to use when signing and sealing shop drawings. So that was the real transition for us when we started to get into that business, where we couldn't, pussyfoot around anymore. Of course, in Part 9, you're basically under the honor system. You're self-labeling, and there's no requirement for certification. So, it can get to be quite a large gray area, but once you start, quoting those big projects, you're going to be asked for test reports. You're going to be asked to demonstrate, do you have the physical testing to back up what you're saying the strength of your product is?
Yes, and I think that's really the big, the big difference between doing work on large buildings versus doing work on Part 9 buildings. For small buildings under the code, up to 3 stories, basically building officials are happy to see that there's labels on the product, and they trust when they see the labels that manufacturers done their homework and everything's fine. But once manufacturers get into larger buildings, 4 stories and up, it might be the same kind of product you sell in the low-rise market, but you definitely then encounter, you might say, enforcement that might be at a higher level. And that's where, the architect or the engineers on the, working for the architect are looking more closely at the performance of the windows, how they're anchored to the building, and have they been adequately tested? Do you actually have testing for the configurations you're supplying to that building? And that's where definitely manufacturers need to have evidence that they've tested or had an engineer actually qualify those configurations. And depending where you are in Canada, there's more or less of enforcement of that kind. But certainly that is something that manufacturers encounter on larger buildings for sure.
So we do have 2 questions here if you're
yes.
ready for that. So it's both from Sunny again. So the first one, can you distinguish the difference with using shoe for mold connections as compared to routed mullion and connection to transfer that load to frame?
So the mullion that I showed that was sheared, it was end milled, to fit the frame profile, and then it was just screwed through the frame. Screws weren't the weakest link. Rebar wasn't the weakest link. The shear was the weakest link in that case. I know there are other types of joints that are possible. For example, welded. There's these V-notch welding systems, and that might actually be quite strong as well. But I think the central message is that you can't really you can do a calculation of bending of a mullion, but you can't really validate the connections by calculations, because it's a more dynamic thing that's going on at the ends, with the twisting and the rotation. So the only way to do that is by physical testing. And if you want to have assurances, you really should be testing the largest mullions at the longest spans, at the minimum design pressure that you require that mullion to achieve at those larger sizes. And then you could assign, by calculation, a higher design pressure at smaller sizes using calculation techniques like AAMA 450. And you would have to have those done by a third party if you don't have engineering staff, because AAMA 450 is very clear that this is work that needs to be done by engineers, not by lay people. So if you don't have your own engineering capabilities, then you have to rely on professional advice.
Anything to add, Al, to that?
No, I think Dave's covered it. Yeah, continue.
So we have another question here. Can routing the mullion and suit the same? Routing the mullion and suit the same purpose as a shoe, or is shoe a different material?
Well, I think the proof is in the pudding, so to speak, right? So you need to validate it by physical testing, whatever your solution is. And you could do that, by physical testing of a complete unit, or you could do that, by placing a point load on the mullion in-house, and doing kind of a rational analysis. But in order to do that properly, I think you would need the engineering advice from a professional engineer.
Okay. We have John. Go ahead.
If I could just comment,
yes, for sure.
A lot depends on the window system and the window system's geometry and how thick the extrusion walls are. So, for example, the one that failed in your test there, Dave, there's this up to a certain pressure, that mullion would have been fine.
Yeah.
Right. It broke because, in that test, you reached the limit. You found out where the limit was. And in that case, the failure limit was lower than what you wanted.
Yeah, we
for
would
that
have wanted it to
particular
be
connection.
1.5
So,
times, the design pressure, right? And it was
yeah,
when it's
yeah,
not 1.5 times the desired design pressure, then you need to do some redesign to get it to be stronger.
yeah. But I mean, if you're designing a product for a higher wind load, it's going to be different than if you're designing it for a lower wind load, right?
Yeah,
So, there may be products where that routed connection is good enough. And of course, there may be products where it's not enough and you need some other kind of a bracket or connection or some other way of transferring the forces from the mullion to the frame. So it's not something you can just say, this is what you do. It's very much particular to the geometry of the system, the materials of your system, and the sizes that you're testing, and the pressures that you're testing under. So, everything has its limit, and the question is your product line performing to the pressures you want at the sizes that you're selling? That's really, what your objective is, because whatever you sell, at whatever rating you sell it at, you need to have the product qualified to those conditions. And so it could be two manufacturers fabricating the same system. One's in Lethbridge, and one's in, downtown Toronto. And the product that is perfectly adequate for downtown Toronto might actually be failing in Lethbridge, just because of the high wind loads there. So there's not a one size fits all answer to these questions.
Mm-hmm.
Yes, that's true. I think the challenge for manufacturers is when you've got an automated order entry system, is how do you validate those configurations in your order entry system? So another kind of path that we went down, at one point we had an order entry system where you selected available configurations and you selected them in certain sizes. Then we changed to an order entry system, was much like the previous one, where the salesperson or customer can dream up a custom configuration, build it as Lego, and so how do you qualify the mullions in a system like that? The solution we implemented was to have automated mullion validation using a combination of test reports and calculations under AAMA 450 that would warn the user, this mullion is not strong enough, it's deflecting too much at the required design pressure, you need to go change to a reinforced mullion. And if that's not strong enough, you need to change to a combination assembly with a heavily reinforced mullion that we would refer to internally as a packed mullion.
Okay, so
there's different approaches that you can use for that. I think, the minimum approach would be to have span tables that are included in your system that it's referencing based on engineering calculations. The most sophisticated system would have some kind of software module in there doing calculations according to the reference standards.
Okay, great. We do have a couple more questions here, so I'll start with which I feel is more of a comment or an information here, but John Hill is saying, consider consulting with your PVC extruder to see if mullion evaluations were conducted in the design of the mullion system. Extruders may be able to share such evaluations with their customers. So it's a point he's making.
Well, that's a good point. However, you need to be aware that in some jurisdictions, they will say, or architects, let me put it this way, we quite frequently see on architectural specifications that they're not willing to accept vendor test reports from extruders. They expect the manufacturers to have done their own testing.
Okay.
Because you don't know if they're manufacturing it the exact same way as the vendor manufactured their unit, and that's the vendor is coming in and inspecting the manufacturing processes of the manufacturer. You need to have that close of a partnership with your vendor in order to ensure that their reports were valid for the way you're manufacturing your product.
Okay, I see. Okay, we do have Sandy with another question. He's asking, for mold cross connections, are there any particulars to gaskets, example thickness, compressionability? This is more water performance related and not structural.
Yes, you're going to find that you need to use gaskets at those connections. You identify your plane of water resistance and make sure that it's properly gasketed. So I know that Al might ask, when you're making any old configuration that a customer can dream up as Plygem does, wouldn't you have to test all those configurations in the laboratory for air, water, and structural? Well, that would be an impossible amount of testing. So the approach that we take, and it's not because of NAFS, it's because of field water testing on Part 4 projects, is we have a water test well where we do quality control testing on products that are randomly selected. And then over time, you're testing every possible combination for the water separately and making sure, most importantly, that your workmanship is good. And so we use it to catch workmanship issues, where someone's not butting the glazing tapes correctly and not providing the correct amount of sealant. And we do not want that failing in field water testing. So, when this happens on our test wall, the green light turns to a flashing red light, and quality goes down to the line that glazed this unit and starts reading them the riot act, because it's a whole world of pain when you start failing field water tests. I mean, they will say, okay, you remediated the glazing on this one unit that failed. Now you need to test 10 units to prove that the rest are all good, or you need to remediate every unit in the building with what you did to the unit that failed. It's a very miserable situation to wind up finding yourself in.
And really, I think the companies that actually do the Part 4, Part 5 multifamily projects are the ones that learn to implement the most effective quality management processes. In those jurisdictions where there is field testing typically required, this is the case in BC and in some other provinces as well, that when your products are being tested in the field, they're being installed by people that are not your own installers. And the risk of failure of a water penetration test is that you could spend an awful lot of money repairing windows on the job site if they fail. And so when manufacturers jump from Part 9 buildings to larger buildings, that's one of the first lessons they learn. And I think the ones who stay in the business do exactly what Dave has said. They do in-house water testing as a quality control measure. And I used to work for a company that was in that market and did the same thing. We built our own test chamber and did our own water testing. And like you say, you do it regularly, randomly, and that way you catch production problems and you prevent little problems from becoming very big, expensive problems on the job site. But the other thing that you learn from doing that water testing is to understand what parts of your product are vulnerable. Depending on your glazing system, depending on your assembly system, there are certain things that go wrong. Sometimes you get parts from your suppliers that are out of tolerance, and you're doing everything right and the product fails. And it's not because you did anything wrong, it's because there's tolerance variations in the components that you're getting from others. And so that's a whole other subject that we could spend time on that goes beyond Mullions, but it's worth touching on since you brought it up and since our questioner brought up the gasket question.
Yep.
Okay, so guys, I just want to tell you we have another 3 questions here, so I think I'll go through them one by one.
Sure. No, it's good to hear from our listeners.
Yeah, awesome. So we have Rocco Cirelli asking, obviously different materials provide better or worse thermal performance. Ideally, steel reinforcement may provide the best performance. Should a manufacturer have thermal testing for all reinforcement combinations, whether it's steel, aluminum, fiberglass, or wood?
Well, you're touching on what's basically a dirty little secret in our industry, which is the NFRC thermal simulations are done on standalone units. And so you don't need, on mulled units, you don't need to do any further testing. And so the ratings that you're putting on there, according to the CSA standard or the NFRC standard, are based on units without reinforcing. And so when you have a huge steel rebar in a packed mullion, it is going to cause more thermal transmittance, and you might even run into situations where you're getting frost on the interior of the mullion in very cold climates, when the customer thinks that they have bought a high performing window system and they're getting frost on the mullions. So nobody has come up with a method for addressing this, and if they did, obviously the two requirements would be in conflict when you're using steel reinforcing. So on our most recent products, like the one I illustrated earlier on, we try to make sure that there's you got two walls of vinyl on the inside before the reinforcing, and two walls of vinyl on the outside to prevent the possibility of frost occurring on that mullion in very cold temperatures. But it's certainly not going to have the same low level of thermal conductivity as your ratings might imply.
Okay.
And maybe I'll just add a little bit to Dave's comments here, is that the NFRC and CSA system for thermal performance of windows is really designed to compare products against each other. Compare A to B. I'm looking at two windows. They're both very similar. Which one has better energy performance? And it wasn't primarily designed for estimating the energy performance of the windows in a building. It was more just to choose products. And I think when they developed that system, they figured that it was conservative to ignore mullions, because if you take two products, basically, if you use the individual unit ratings for a product that has separated by a mullion, you're either going to have two frames as the mullion, or you're going to have some other mullion, an integral mullion, but the two frames are going to have higher conductivity, and they probably figured that was close enough to cover the mullion cases. And so, in fact, the energy performance rating system we have in North America does not address the mullions of typical windows. They only address the mullions in a window wall system or a curtain wall system, where the mullions definitely are evaluated. So yes, the mullions, the extra into a mullion is essentially ignored by the code. So I think Dave called it a dirty little secret, in that people assume that every part of every window, is thermally efficient. And the reality is that it's not that the manufacturers have a dirty little secret. They're not doing something they should be doing. It's a case that the standard that we have has chosen to ignore the question of the heat loss through mullions. So it's not something that manufacturers are responsible for. It's just that the standard ignores that and figures that they've got that covered by the fact that they're assuming that there are two window frames always whenever there's a mullion, and that is expected to be good enough for code compliance. So just wanted to clarify that this is not an industry failing. It's actually part of the design of our energy regulatory system that they've chosen not to actually evaluate that properly.
Sure, and just to give you an idea of the impact that we're talking about here, you will find, like, let's say you needed a U1.4 window because you're in the city of Vancouver. You will find that with a single low E coating in a double glazed unit, your casements and direct sets will meet it, and your sliders won't. But in reality, you're filling an opening in the wall, and you're either filling it with a picture unit, a direct set unit mulled to a casement with a mullion, or you're filling it with an XO slider with interlocks, and the interlocks are reinforced with steel, and that's why the slider doesn't make the 1.4 when the casement by direct set does make the 1.4, where in reality they're approximately equivalent if they've got the same glazing.
This is true, and this is in effect, this is one of the things that kind of penalizes the slider and makes it look like the worst option, simply because it's mullion. The interlock is actually included in the analysis, and the other window's mullion is ignored in the analysis. And I would call that a flaw or an imperfection in our window energy rating system. And yes, it does kind of unfairly discriminate against sliding windows in that regard. It makes it harder for them to qualify for sure.
Okay, so let's move on to the next question. So Sunny's asking, so gaskets as well as caulking is recommended typically for these connections, or can gaskets alone suffice? Example, rubber gaskets.
Well, you would need to experiment and figure out what is going to do the job for you. And really the only way to do that is to do that in physical testing. We use closed cell foam gaskets. We never tried rubber gaskets. A combination of closed cell foam and sealant has worked pretty well for us and for many other manufacturers.
Al, I saw you laughing, so I guess you.
Well, no, because you can't just say this is better than that without actually testing. And but I think Dave is right. Closed cell foam is a more common material to be used in that situation. And but whatever you use needs to pass testing. And
and from a design perspective, I think the only thing I'd like to point out, it needs to have some body. So if you have a wood window system and you're putting sealant in the joints between the vertical member and the horizontal member, and you're squeezing that sealant down to a fraction of a millimeter of thickness, it's going to get shipped to job site and that seal is going to be broken. Somebody's going to drop it on the corner. It's got zero ability to flex. And you're going to do field water testing on your wood windows and it'll be leaking at the corners. So if you're using sealant, you need to ensure that there is a good body of sealant that's able to flex.
Good point. And these are lessons learned in the real world, right? So
you bet.
Yeah.
So we have Adrian Edge asking or mentioning, so the demand for larger windows and doors is likely not to decrease. As the fenestration industry adapts to these sizes, the reinforcing is growing in the total percentage of windows and door material. Dave, are you experiencing any pushback as far as the reinforcing acting as a thermal bridging from the energy audit? And if so, do you have any suggestions on how the industry will continue to grow in both directions of energy efficiency and larger fenestration systems?
So energy auditors are blissfully unaware, as far as I know, of this issue. Where the pushback will come was when a customer has ordered your highest performing triple glazed window and they're not getting any condensation anywhere on the glass or even on the edges where the spacer is because you're using a low transmittance spacer. And then they see frost or condensation on the mullion. That's where the pushback's going to occur. We are just kind of gradually changing our mullions to try and come up with designs that are not susceptible to that in very, very cold environments. And we have a solution that we can apply in the field when there's a complaint. We haven't totally solved that issue yet, and it's definitely an issue that will need to be solved by manufacturers in colder environments as the windows start to get more and more strongly reinforced.
Okay, good. Al, anything to add to that?
No, I think Dave's covered it.
Perfect. So we have Doug Thompson here. Do you foresee thermal performance testing to include more intricate composite designs? And should manufacturers push this due to proprietary innovations in those designs?
So here's what I see happening. As we start to go towards net zero housing, these energy modelers, they should start to model not just the window on a naive basis, they should be modeling the window and its installation properties, like how much insulation you've got in the gap between the rough opening and the frame. I mean, in some jurisdictions like in BC, they completely leave out the insulation because they're using that a cavity purely for the control of water and venting water to the outside so the windows don't leak. And as far as they're concerned, the thermal properties of that gap are play second fiddle. As you know, Fenestration Canada, together with John Eakes, have a research project going on right now to try to identify how to have an installation that handles the water like in BC, but also has the proper thermal properties. So once energy modelers start including that in their calculations, surely they're going to start to take an interest in the thermal properties of the mullions as well. And so, yes, I think we will, as we approach 2025 and 2030 and try to meet our aspirational goals for market transformation, I believe all of this stuff is going to become scrutinized to a much greater degree than it currently is. And the fact that so many people on this call have brought this topic up, I think illustrates that people are starting to become aware of that.
Mm-hmm.
I think the concern about the thermal transmittance through reinforced mullions is probably greater in colder climate areas. So it might be more of an issue in northern BC or, Alberta and central Canada, certainly in Manitoba. And I think in the cold climate markets, there's more of a concern about condensation. And certainly that's where manufacturers are probably paying more attention in their window designs to that issue. I know that some manufacturers use materials such as fiberglass as reinforcement, and possibly even wood, as a reinforcement in a vinyl window system, just to have something that's less conductive than steel. So, definitely, I think in condensation sensitive markets, there's a lot more attention probably being paid to that issue than it might be in the lower mainland of BC.
I think there's an opportunity out there for somebody to develop a strong mullion based on new technology that's not thermally conductive.
You're thinking of a different material.
Yes, different material, or having, if you could bond steel to vinyl, then you could bond a piece of steel on the interior on the outside and bond a piece of steel on the interior in the inside of the cavity or some other material and not have a thermal bridge from front to back. You would just need to figure out how to bond that reinforcing material to the vinyl strongly enough that the vinyl can act as the shear, to transfer the shear from the exterior surface to the interior surface. So for those of you out there who are developing, extrusion technologies, perhaps you might want to think of trying to pioneer something new like that could give you the best of both worlds: the thermal conductivity of a hollow vinyl extrusion with no reinforcing in it, and the strength of something that has steel or something else that's quite rigid.
Okay. Yeah, I think if people put their minds to that issue, they could certainly come up with some interesting ideas. I know that one option that I've seen and wanted to explore several years back when I was in a manufacturing environment was, 3M has some very powerful adhesives, very powerful adhesive tapes that actually are used to glue signage onto the cladding at the tops of high-rise buildings. And some of these adhesives are quite strong, and I think there's a real potential to use an adhesive to bond a structural reinforcing, probably more on the inside of a window than the exterior, because you wouldn't want a failure of the adhesive to lead to stuff falling off the building. And clearly, if you had something fall off on the inside, you would be able to deal with it and know that something's missing on your window. But I think if it was possible to apply them under the right quality control conditions, and also perhaps use them in environments where the loss of the reinforcing, should it debond, be non-catastrophic in terms of its performance. But still, I think there are I think adhesives have probably not been given enough attention here, because we essentially glue our large airplanes together, and so we have technologies that are very, some pretty powerful adhesive technologies that have not been really utilized in the window industry, that I think could potentially be utilized in thoughtful ways. So, but that's my blue sky thinking.
I once did a kind of an intellectual exercise by calculations where I say, if we have a product series that has aluminum clad on the outside and aluminum clad on the inside, and supposing we riveted that cladding to the vinyl member, how many rivets would you need to transfer the shear stress to make sure that they acted as a composite member? And it was like a ridiculous number, like 1 rivet an inch. So,
But, interesting you mentioned that. We were involved with a manufacturer that had, it was a European technology, and they had an aluminum cladding system that bonded, that mechanically locked to the PVC so well that it was structural. And in fact, they were using it, for example, they could build very large sashes, door sashes, where the structural rigidity of that PVC frame came from the cladding that was designed, that the joints were designed in such a way that, and it bonded by friction so well to the PVC that the aluminum was actually performing as a structural element, essentially on the basis of friction and tight metal to metal connections were on the exterior of the product. And again, there might be ways of incorporating aluminum cladding where it effectively has enough of a friction bond, perhaps, to perform that function. So there's the R&D shop, eh?
Yeah.
But we thank our viewers for the questions. It's always good to address the issues that are top of mind in people's minds, and clearly there's some thoughtful thinking going on about the joints between mullions and window frames, and between mullions interconnecting with mullions. We're coming to the end of the program today.
I'd just like to mention one thing,
Yeah.
Al.
Certainly.
I am co-chairing the technical committee dealing with the AAMA 450 standard to expand its scope.
Yes, please do. Tell us about
that. With composite mullions. So a low NAFS refers to the use of AAMA 450 for both composite assemblies and combination assemblies. You get into that document, it's really only giving you guidance on the combination assemblies. So we have expanded that document, and we've added guidance for composite units, and it is out for committee review right now and public review. And hopefully, if there's no major objections to it, it should be published as early as the beginning of next year, and be helpful in this regards. Because when I first read NAFS, it terrified me, to be honest, the amount of testing that this could have possibly triggered for manufacturers who are using primarily composite assembly. And so we want to put them both on on a level playing field, because one is not really superior to the other. I mean, certainly combination assemblies are known to have problems with leaky mullions due to workmanship over and above intermediate members.
So you're referring to an update to the AAMA 450 standard, and of the update that it would now address integral mullions in composite unit products. And that I discovered actually in a phone call with FGIA last week, that in fact that document is available for public review on the FGIA website. And so we're going to send out a news bulletin to our members to let them know, but it'll be an email, I guess, to our members to let them know exactly where they can download the document if they want to see it, and see what are the proposed changes to AAMA 450 to address these composite unit products. And I would like to personally thank you, Dave, for bringing that issue to the attention of FGIA, the need to adapt the document to address integral mullions and composite unit products. I know you and I have talked about that, probably several years ago, and I do appreciate that you've taken the initiative to get involved there and get that task group going to be updated in this way. So we really appreciate your leadership in this area. Thank you.
Well, thank you, Al.
So next week on our show, we're going to have an engineer from UL who's going to talk to us about AAMA 450 services that test labs can offer, the engineering services that engineers and test labs with engineers that do AAMA 450 work that they can offer, and how that can benefit you, the kind of information they'll need from manufacturers, what they can do for you. And so we're going to be talking more about the use of AAMA 450 by manufacturers in next week's show. Okay. So thank you, Dave. And thank to all our listeners. We'll be back on the air next week.
Thank you.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.